first thing I want to do is thank Tressa, who's done just a yeoman's job of organizing all sorts of cats into a herd to make this happen. She did a great job in so many areas. We appreciate it. This is not the first time I've been here. Last time went smooth as silk, and so far we're on the same track. Want to thank her admins, Janelle and Erica, the editor, and Janet is our graphics people. They are responsible for the booklet see, that you have in front of you. You can take this home, of course, make notes in it, and give you a little late night reading if you don't want to purchase my book, which is, I certainly understand that. But we have a lot to do today. I'm excited about this. Glad to have you here. We have a lot to cover about sampling and statistics. I think there's only one or two formulas, okay, very few Greek symbols. I learned a long time ago you can put people to sleep very quickly doing what I do. And in fact, my wife told me after seeing my short course that her root canals were less painful. So, and I had to take a picture of myself on captive audience with the Department of Corrections. So it's a challenge. I tend to create graphics rather than words. I'm a visual person and I like to see pictures. So we'll have lots of pictures. But the one thing I want to emphasize today is, despite the massive amount of material we have to cover in the next 2 days, is that this is your class and I like questions. You can always take the manual home. There's a copy of the white paper, which is now upwards of 65 or some, growing pages. And that's a good resource, but you have me just for 2 days. If I have to go through the slides a little faster to answer somebody's question, that's a good thing, okay? We have a lot of diversity in here, people doing different types of pile sampling. This is sort of the story of my life. I started in the mining industry and then went into the environmental industry. Now I've been the last few years in the nuclear industry. I've also done agriculture, pharmaceuticals, cereals, things like that. And sampling is, in a sense, the same everywhere. But everybody looks at it a little bit differently. And so what we're going to do today is try and design some scientific principles that you can apply in any sampling situation. I was just informed of another new application that we might have to discuss right before the class. And so what I like to do quickly is start with, make sure I've got this all working. Okay, that's me. I'm with a company called AECOM, one of those nerdy engineering names. Not even sure what it stands for, but that's me. I'm with the Nuclear and Environment. I work in Aiken, South Carolina. It's a DOE facility, a lot like INEL, or INL, whatever, INEEL, I forget what they call it these days. It's up in Idaho Falls. You've probably heard of that. Anyway, Savannah Rivers, another big group like that. I don't work at the site, but our company has run the operations for years, so I know that. They have their own sampling challenges, just as environmental, mining, and other industries do. Okay, so one thing I always like to do is talk about why we're here. Okay, and the reason is that we need to learn about sampling, and it can be a dry subject. And we're going to, after lunch today, actually go through an experiential exercise and hope that that actually brings it to life a little bit so that you can remember an experience and see what I think will be some surprising results to actually sampling simulated soil material, so that it's just not abstract, it's not formulas, it's not even pictures, it's an experience. I couldn't bring my bead models because we didn't have time and budget this time, but this will be a good experience. Again, there's some real surprises. So as a teacher, I'm also a leader, and in my mind, you're a leader if everyone else's success is my first priority. Okay, so in the next 2 days, I want to make your success my first priority. So ask questions, bring out things, because I have a lot of experience, but I don't have nearly as much experience as the volume in this room. And so I want to add, kind of like yeast to dough that rises, add to your experience and grow you, grow this organization of DEQ, grow you. I'm a consultant, so if you're a consultant, I want to grow you. If you're with a city, grow you, so that, I've seen this twice now, and DEQ here has a really good program. They've got good people. We want to raise the bar even higher. As far as I know, there is no other state that has a white paper like this. There's only 2 that have guidance, and they're not as long as the white paper, which doesn't necessarily mean it's better. But in any event, you guys are kind of on the cutting edge, all right? So I hope you take this opportunity to learn, to ask me questions. In the end, I learn as much or more than you guys too, all right? I love to hear the problems. We wrestle with them. I don't have all the answers. Pile sampling, it turns out, is one of the most difficult types of sampling there is. And so we will have challenges. We will go through case studies, and those were written kind of on the fly. They're really a stream of consciousness. We will change them. We will improve them this week. So we have a lot ahead of us. And so let's go back to, the why. Basically, we want to learn to make accurate decisions. Sampling is all about making decisions. Why would you go out and take samples if you didn't want to make decisions? Okay, maybe in a research situation, possibly, but you're going to spend a lot of time, money, and other resources sampling, and if you're not going to make a decision, you probably shouldn't be out there doing it. These decisions apply to human health and safety, environmental health, regulatory compliance, and legal issues. You know the drill. You're all in regulated industries or part of the regulator community. And so these things all interact. They're complex. People have agendas. There's all sorts of rules that intersect. Sometimes they conflict. And so we have to fit into that overall structure, and it can be very complex. How do we do it? Well, we want to implement systematic planning. This is something EPA has been mandating for, I'd say, a quarter of a century, ever since they really kind of started getting their act together after they passed RCRA and CERCLA. And they take project objectives and constraints and then overlay the safety, costs, schedule, decision certainty, and environmental impacts that go along with that. And that's a lot, okay? Just the decision certainty based on the sample data that you collect is a big issue, and that's really where we're going to focus today. My company is big into safety, especially nuclear safety in Aiken, South Carolina, so we'll talk about that, but it runs right through Tress's biosolids, down to the other case studies for pesticides, dieldrin, or petroleum contaminated soils. Doesn't really matter. Typically you're sampling because there is a potential risk to human health and the environment. And obviously that's the environmental impacts. We apply scientific and engineering principles to our data quality objectives development so that we obtain representative sample data. This is one of the trickiest statements in all of science, representative samples. What is that? We're going to talk a lot about representative samples because first we're going to have to go back and define what a sample is. We'll spend a lot of today talking about what a sample is not, and why it makes a difference. And you're probably thinking, what does that mean? Well, it means a lot, but we'll open up the window slowly here this morning. We also want to achieve multi-party consensus because the DQO process was started because I know my experience in Superfund litigations in the early 80s was people went out and collected data, and then they brought it to the regulatory agency. The people collecting data didn't really understand what they were doing. The people who were evaluating the data didn't understand what they were doing, and they had conflicts, okay? And they didn't talk to each other. They do something, they throw it over the fence, the regulator take it, throw it back. Now we're trying to get people involved up front to solve what I call global issues, and then go out and fine-tune off in the consultancy or the corporation or the city who's managing the sampling, the individual issues, develop the sampling plans, the quality assurance plans, and so on. And so we have to work together. Sometimes that's easy, sometimes it's not. Hopefully, if we can agree on the science, that makes some of the other political and legal and other issues that come across a little easier to solve. And so what are the tools? The tools are the guts. First, we start with data quality objectives. This is something EPA developed. We'll see it's based on the scientific method, very formalized, but very flexible all at the same time. It's also iterative, so if you need to do it more than once, that can be done. And if you remember the old days of environmental remediation, a lot of times you went out to the field several times. And we also have sampling theory and practice. This was a technology that came from the mining industry. In fact, both of the things I specialize in, sampling theory and geostatistics, came from the mining industry, because sampling was very important. Because if you did your sampling incorrectly, it hit you right in the pocketbook. You know, if you're mining gold, you don't want to be throwing the gold in the waste dump and processing waste as ore at the mill. That costs you a lot of money. It's really not a lot different in the environmental world. When you sample, you want to make sure that when you get done sampling that pile, your decision to send it to a recreohazardous waste landfill or put it back on the site or sell it as compost or give it away is correct, because there's financial implications and there are human health and safety implications. So we want to be sure that we have things right. In this world, and really Tressa can speak better to this than I can, we have all sorts of regulations. Whoops. Where's my little... there we go. We've got the 40 CFR 503 requirements. Those are for the biosolids. Okay. And I'm sure there's others. For the environmental world, there are others. And the IDAPA, and I won't read the numbers, you're all familiar with the regulations in your area. So everything's got to fit. And that's where the data quality objectives process comes, is it gives us a process by which we meld, or at least try to, all those regulations with the science, with the budgets, the schedules, the cost, all those items that come along with the project. Okay. Now it can be a little bit mind-boggling to get this all in your head all at once. And last year we were doing a proposal on, actually it was a deep borehole drilling project for DOE. And they had DQOs and they had all these diagrams, and I thought, well, maybe we can do better. I don't know if it is better, but we're going to use a little bit what I call a breakthrough diagram, where in the middle are kind of the problems and the starting point, things you know, like regulations. And then you move out into other areas. Let's see if I can read this. Regulatory thresholds and things like that. Then we bring the systematic planning process, data quality objectives. Then we move out into the actual sampling and then into decision making. And each one of those processes has a lot of steps and a lot of interactions involved. And so this kind of summarizes it. I sort of went for the biosolids, but I think it applies to a lot of the sampling techniques. We had a different one for deep borehole. We have a different one for risk assessment. So we can do it for anything, but hopefully this is kind of one diagram. The idea is that when you're in the interior, there's a lot of unknowns. You're struggling with issues. As you work your way out, you get increasing levels of knowledge, safety, data quality, and confidence in your decisions. And that's one thing we're going to stress in the next 2 days, is being confident in those decisions, because you want to make sure the material that you put back on the site is not going to harm people. You also don't want to send it to a landfill because unnecessarily, because that's going to cost you a lot of money. Again, housekeeping, you've got the course notes. They have the presentation slides. They have the class exercise that we'll do after lunch today. That's a physical, whoops, I got the wrong buttons here. We have physical models. It's called I'm Peppy. It's little tiny, basically sand-sized pasta. We're going to sample them. There's particle contamination in it. We're going to see some surprising results on how our choice of sampling devices influences the statistical distribution and thus the decisions that we might make down the road. And so that's it. That's the intro I have.